All right, mathematicians, today we're going to continue simplifying radicals, and we're going to look at a little bit of radical functions there at the bottom of the page. So today we're going to be simplifying radicals that have variables in them. So to do that, the root is going to divide a variable's exponent. So that's all you have to remember. A root will divide the exponent. So remember, a square root has an understood 2 for an index, so the root will divide the exponent. So what's 2 divided by 2? Well, that would be 1. So z to the first, but we don't put to the first. So let's look at 2 as well. Remember, that square root has an understood 2, so we'll take the exponent, divide it by the root. 6 divided by 2 is 3, so that would be x to the third. On number 3, you want to do it piece by piece. So you have the cube root of 27. So what's that mean? What number times itself 3 times is 27? The cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27. And then we'll do the y to the 6th part. So we'll take the variable's exponent and divide it by the index. 6 divided by 3 is 2. So it would be y to the 2nd. So the cube root of 27y to the 6th is 3y to the 2nd. Okay, so again, this is a square root, so there's an understood 2. I'm not going to put them anymore. So first, what's the square root of 16? 4 times 4 is 16, so the square root of 16 is 4. And then take exponents and divide it by the index. 16 divided by 2 is 8. So it's going to be 4x to the 8th for that one. On number 5, we have a fraction. So remember, again, just kind of do it piece by piece. Do the top, then do the bottom. Remember, this is still a square root, so x to the 4th is going to be, you're going to divide that exponent by 2, so that would be x squared. On bottom, the square root of 25 is 5, because 5 times 5 is 25. All right, 6, we got a few things. It's really not any harder, just 3 pieces. So first, what's the cube root of negative 125? Remember, we can do odd indexes with negative numbers. We can't do even index with negative numbers. So what number times itself 3 times is negative 125? Hopefully remember that 5 times 5 times 5 is 125. But since it's negative, the cube root of negative 125 would be negative 5. And then take each individual exponent and divide it by the index. 12 divided by 3 would be a to the 4th. 15 divided by 3 would be b to the 5th. And if you want, pause the video here and try these next 6. They'll mimic the first 6 that we just did. Try those out, and then we will compare answers here shortly. All right, let's see how you did. 10 divided by 2 gives you x to the 5th. 14 divided by 2 gives you y to the 7th. The 4th root of 16 is 2. And 20 divided by 4 is 5, so 2z to the 5th. The square root of 49 is 7. X squared divided by 2 is x to the 1st. That would be z squared over 6. And the cube root of negative 8 is negative 2. 6 divided by 3 is 2. 12 divided by 3 is 4. Hopefully you did those all right. Let me know if you have any questions on those. Okay, the next thing we're going to do is we're going to be kind of starting to graph some square root and cube root functions. So to do that, you got to think about the domain and things that you could choose for the values of x. So remember that the domain of a function are the values that you can use for x. So in even roots, the domain is all the values of x that produce non-negative numbers in the radicals. Remember, in an even index, you can't have a negative number inside of the radical. In odd roots, the domain is going to be always all real numbers. Keep that in mind when you're choosing values to plug in to the root functions. Okay, so our first objective is going to be what would be the domain of these. So what would be the values of x that we could pick that would produce an answer? So for number 1, we've got the square root of something. So remember, inside of this square root, we can't have a negative number. And the values of x that we pick, we're going to subtract 4 from it. So if I were to pick 0, 0 minus 4 would make negative 4 inside of that radical. I can't take the square root of a negative number. So I couldn't pick 0. I also couldn't pick 1 for the same reason. 1 minus 4 is negative 3. I can't take the square root of a negative number. I couldn't pick 2 for the same reason. I couldn't pick 3 for the same reason. The first number that I could pick is 4 because 4 minus 4 gives me the square root of 0, which I can do. I could pick 5 because that would be 1, which is a positive number. And I could pick 6. I could pick anything that's 4 or bigger. So the domain for this is going to be x has to be greater than or equal to 4. If we pick anything that's that's less than 4, it would make a negative number inside of that radical. On number 2, I noticed the odd index. Since we have the odd index, we can have positive numbers inside of there, negative numbers inside of there, and 0. So in any odd index, it's always going to be all real numbers. So think about 3, pause the video here, and see if you can write the domain before I do. Okay, let's see what you came up with. So whatever you choose, you have to add 5 to it. So hopefully you didn't say 5 because 5 plus 5 is 10. And that works, that's fine, but can I pick 4? 4 plus 5 is 9. Yeah, could I pick 0? 0 plus 5 is 5. That's a positive number. Could I pick negative 1? Negative 1 plus 5 is 4. That's still a positive number. So what you really need to do for these is you're going to take the equation or the thing under the radical, and you're going to kind of just set it to has to be greater than or equal to 0. Because remember, whatever's under the radical has to be greater than or equal to 0 for it to be able to take a square root of it. So you subtract 5 from both sides of the equation, and you've got your solution. X has to be greater than or equal to negative 5. Because negative 5 plus 5 is 0, and that's the minimum value that I could have under a radical. And then 4, you see that odd index. So again, all real numbers is the domain. Okay. Wow. It says find each function value. So you'll notice they have f of somethings, g of somethings, and h of and w's of something. So we're going to be using those functions up here. So hopefully I didn't muck them up too much with my circlings. So the first one says find f of 8. So that means I'm using the f function and I'm plugging in 8 into the function. So the f function, I'll write it down, is the square root of x minus 4. So I'm plugging in 8 for x. So it's the square root of 8 minus 4. So that's the square root of 4. And we know that the square root of 4 is 2. Okay, number 2, again, we're using the f function. So I would write that down, the square root of x minus 4. And the square root of x minus 4, this time they say plug in 6. So 6 minus 4 is the square root of 2. And when we are going to graph this, we'll want kind of a decimal approximation. So we should pull out our calculator and type in the square root of 2 to get a decimal approximation. It's about 1.4. So I would write that down. That's going to help you graph it. Okay, number 3, they say this time we're using the g function. So my g function is the cube root of x plus 2. And they say plug in negative 1 for x this time. So that's the cube root of negative 1 plus 2. What's negative 1 plus 2? That's 1. So what's the cube root of 1? What number times itself 3 times is still 1? That is 1. On 4, once again, we're using the g function. So I would write down the g function, the cube root of x plus 2. So that would be the cube root of 1 plus 2. That would be the cube root of 3. Now there is no number times itself 3 times that is 3. So that's one where you have to type it in. Remember how to do that. 3, you're going to hit second. The button, that looks like that. It's got the x next to the radical. It's above the square root button on your calculator. And the cube root of 3 comes out to also be about 1.4. Okay, on 5 and 6, once you pause here, try those. We will compare h function for number 3. The h function is the square root of x plus 5, so that would be the square root of 11 plus 5. That would be the square root of 16, which is 4. That's a 4. On 6, do a negative 5. So the fifth root of x minus 7 for the w function. So that would be the fifth root of negative 5 minus 7 more. So that's the fifth root of negative 12. That one does not come out to be a whole number. So again, you're going to type it into your calculator. Fifth root of negative 12 comes out to be about negative 1.6. If you need any help with that, let me know. All right, on the back, we're going to graph some functions. It tells us that we should choose x values that are convenient. So what does that mean, convenient? Well, if I'm taking the square root of a number, I'm going to pick numbers that are perfect squares, so I get whole numbers. I don't want to get these, like we got on the front. I don't want to get these nasty decimals because those are harder to graph. So I'm going to pick values that are convenient for me. So on the f function, I make an xy table. We're going to pick a few values that are convenient for us. We're going to pick 0 always. And then what are some perfect squares? 1, 4, and 9. And that's going to be as many as we can graph. Okay, so we're just going to take these 4 values and plug them in. If we plug in 0, what's the square root of 0? Still 0. What's the square root of 1? Still 1. What's the square root of 4? 2. What's the square root of 9? 3. So we'll plot those points. 0, 0, right there at the origin. 1, 1, right 1, up 1. Right 4, up 2. And then right 9, up 3. So what this graph looks like, it's super curvy at the start, and then it kind of starts to flatten out. That's what it looks like. So it's kind of a ray, but it's non-linear, right? Because it's not a straight line. So square root, cube root, any root function is going to be non-linear. It's not a straight line. Okay, for the g function, it is the cube root of x. So this one, we're going to pick perfect cubes, but remember with cube roots, we can also have negatives, so we need to pick some of those as well. So we always want to pick 0, that's easy. What's the next perfect cube? Well, 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. And that's as many as I can graph because I picked 3. It would be at 27 because 3 times 3 times 3 is 27. So I wouldn't pick 27 because that's going to be off the graph. Now if I pick 1 and 8, I'm going to pick their opposites, negative 1 and negative 8 for cube roots or fourth roots or not fourth roots, but fifth roots or seventh roots. Any odd root, I'm going to pick the perfects and their opposites. All right, so what's the cube root of 0? 0. What's the cube root of 1? 1. What's the cube root of 8? We already kind of discussed it. It is 2 because 2 times 2 is 4, times 2 is 8. Cube root of negative 1 would be negative 1, and the cube root of negative 8 would be negative 2. So we'll plot those 5 points, 0, 0 right there at the origin, 1, 1, 8, 2, negative 1, negative 1, and negative 8, negative 2. So this one is funky. It looks like this. It's curvy. Make it nice and curvy right there in the middle. That's what a cube root function looks like. Pretty interesting. Okay, now for 3, we have to think about our domain more on 3. On the other ones, they were easy because they were just a single thing under there. So let's figure out our domain, and that's going to tell us kind of the values that we should be picking. So remember, you're going to set the whatever's under the radical to greater than or equal to 0. That's easy to solve. You subtract 2 from both sides of the inequality. So you have to pick values that are greater than or equal to negative 2. So those are the values that we're going to pick. And again, we want them to be convenient. So we're definitely going to pick negative 2 because that's going to produce 0 in that square root. We also need to make 1. So what number plus 2 is 1? Well, that would be negative 1. What number, and then what's another perfect square? 4. How do I make 4 under that radical? Well, 2 would make 4. And then what number makes the next perfect square? 9. 7 plus 2 is 9, so I'd pick 7. Now, if this doesn't make sense for you, you can pick whatever values you want, but you have to definitely start at negative 2, and then you can go up from there. You're just going to get decimals if you don't pick these values. So let's plug these in. Negative 2 plus 2 is 0. What's the square root of 0? 0. Negative 1 plus 2 is 1. What's the square root of 1? 1. 2 plus 2 is 4. What's the square root of 4? 2. 7 plus 2 is 9. What's the square root of 7? What's the square root of 9? 3. So now you see why I picked these values. They produce even numbers. If you pick like 5, 5 plus 2 is 7. Well, what's the square root of 7? I don't know. You'd have to figure that out. So let's see here. Let's graph these points real quick, and then we'll be done for the day. Negative 2, 0. Negative 1, 1. 2, 2. And 7, 3. So it looks a lot like the first one. It's just been shifted to the left 2. And if you remember when we talked about shifts last year, that would make sense. When you add or subtract inside of there, it moves it to the left or right. All right, so let me know if you have any questions. Otherwise, get started on my math lab, and good luck to you. We'll talk to you tomorrow. Have a great day. It is a great day to be a mathematician.